In this module, you will delve into the world of regression, a type of supervised learning that predicts continuous outcomes. Unlike classification that categorizes data into labels, regression models output a quantity. You'll explore linear regression, polynomial regression, and various regularization techniques to enhance your model's performance. Understanding linear regression. Linear regression is used to predict a dependent variable, y, based on one or more independent variables, x. The relationship between the variables is presumed to be linear. The base formula for a linear regression model is y equals a plus bx. For example, in a house price prediction, suppose you want to predict the price of a house based on its size. The size of the house is your independent variable, or x, and the price is the dependent variable, or y. By plotting data points of size and price from historical data and drawing a line of best fit, you can predict prices for new data. Diving into polynomial regression. When data exhibits a nonlinear relationship, polynomial regression can model such complexities better than linear regression. Environmental scientists use polynomial regression to model relationships, such as the change in sea level or temperature variations over the years. Let's understand implementing regularization techniques. Regularization techniques adjust the learning process to prevent overfitting by penalizing large coefficients in a regression model. Common techniques in regression include Lasso, also known as L1 regularization. This method adds the absolute value of the magnitude of the coefficient as a penalty term to the loss function. Another technique is Ridge, or L2 regularization. This approach adds the squared magnitude of the coefficient as a penalty term to the loss function. Applying cross-validation techniques. Instead of a simple train test split, cross-validation systematically uses different subsets of the data for training and testing to improve model evaluation. In this module, you learned about the power of regression in predicting continuous variables. Starting with simple linear models, expanding to polynomial regression for more complex scenarios, and incorporating regularization techniques to build robust models, this journey equips you with the knowledge to tackle real-world predictive problems. By engaging with practical exercises and a real-world case study, you're now better prepared to implement these techniques in your projects or further studies in machine learning. Thank you so much for taking the time to watch this online training module. I hope you found it valuable and insightful. To stay updated on upcoming content, including new modules, case studies, and quizzes, be sure to subscribe to my channel and share in your community. Your support helps me create more content that enhances your learning experience. Don't miss out on the next steps to watch other module videos to deepen your understanding and apply the concepts in real-world scenarios. Thanks again, and I look forward to seeing you in the next video.